Hey everyone, thanks so much for joining us here in the Navigant Credit Union Broadcast Center. I'd like to introduce Samuel Myers. He's a senior research scientist in the Department of Environmental Health at the Harvard T.H. Chan School of Public Health. He's also the director of the Planetary Health Alliance. Samuel, thank you so much for joining us today.
It's my pleasure to be with you.
So we really appreciate your time. Research recently published through the Harvard T.H. Chan School of Public Health shows that if CO2 levels continue to rise as projected, the populations of 18 countries could lose more than 5% of their dietary protein by 2050. You worked on this study that was recently published in Environmental Health Perspective. So that's why we wanted to talk to you today about your research, about your work, and about your findings. So hoping you could fill us in a little bit just on what you did and what the work was going into this study. Maybe you can just give us a little perspective here.
Sure, I'm happy to. I guess it's important to start a little bit back at the beginning. So we published a study back in 2014 which showed that when you grow staple food crops at elevated concentrations of carbon dioxide, essentially about where the world was going to be in the middle of this century, that they lose a lot of their nutrients. And this had been something of a controversial question that we ultimately resolved by working with agronomists all over the world, growing 41 cultivars of 6 staple food crops on 7 locations on 3 continents over 10 years to build a really large data set. And then we published our paper in Nature in 2014 and showed that indeed these food crops grown at higher levels of CO2 lost a lot of their iron and zinc and protein. Now the next question is sort of, so what? What does that mean for human health? Why does that matter? And so we've done a series of modeling studies since then to look at what people are eating around the world. And if they continue to eat those foods, how many people are likely to fall into deficiencies of zinc, protein, and iron as a result of this carbon dioxide effect? And so the study that you're referring to was one of our papers looking at the risk of protein deficiency. And what we found was that around 150 million people in the world will get pushed into protein deficiency as a result of the CO2 effect, in addition to hundreds of millions of people who are already suffering from protein deficiency who would experience exacerbations of that health problem.
So what we're looking at here is research that you have come over data collection of many years. Really, would you call this a public health crisis in the future?
Well, I wouldn't use the word crisis lightly. I would say that this is part of a public health crisis, which is what we're doing in the field of planetary health. And so the crisis is that human beings are disrupting just about every natural system on our planet. Certainly the climate system, but the deep oceans, the atmosphere, land cover, the geochemical cycles that cycle nutrients around the world. And as we disrupt all of the natural systems on the planet, we're discovering that there are enormous health impacts of those disruptions. And that, taken together, they do represent a public health crisis. So this is one small piece of research that's part of this larger field of planetary health.
And the numbers that you cited in not only this protein study, but in the zinc and the iron study, they're really a little staggering for someone that's not as involved in the research as you do. Someone just like me who's reading this for the first time that hasn't been exposed to these numbers. Can you tell us a little bit about the findings?
Sure. I mean, they are staggering numbers. And the fact is that we're talking about around 150 million people being pushed into protein deficiency, somewhere between 150 and 200 million people being pushed into zinc deficiency. And those, as I say, there are already around 1 billion people who suffer serious health impacts as a result of those deficiencies today, whose deficiencies will be made worse. In addition, we looked at the question of iron intake, and we know that iron deficiency is another enormous public health problem today that affects over 1 billion people. And we asked the question, for the vulnerable, the most vulnerable people, who are women of childbearing age and children under the age of 5, how many of them are living in places which already experience high rates of anemia, which is the sort of most obvious manifestation of iron deficiency, and who will lose significant amounts of their dietary iron as a result of this CO2 effect? And what we found was that 1.4 billion people, with a B, fall into that category. So 1.4 billion women and children live in places where their rates of anemia are greater than 20% and will lose more than 3.8% of their dietary iron as a result of rising carbon dioxide. So there's no question that these are large effects.
So as we are continuing to look at this research, are there certain, and you just mentioned women of childbearing age and so on, are there certain populations that are more at risk than others, whether it's age groups of people, because we're looking out into the future, are there age groups, are there people in certain countries or regions that are more at risk than others?
Well, you're raising a really important question, which we think of as the equity question. And so one of the really fascinating things and scary things about this research is that it highlights an issue of equity. If you think about who are the people who will be responsible for the carbon dioxide emissions to get us from here to 550 parts per million by the middle of the century, and then you ask, who are the people who are going to experience the nutritional deficiencies that we're talking about? They're nearly mirror images of each other. So it's the wealthy people in the wealthy parts of the world whose carbon footprints are the highest. And it's the poorest people in the poorer parts of the world who are most vulnerable to these deficiencies, primarily because they have very little animal source food in their diets. And so animal source foods tend to be very rich in iron, zinc, and protein, and are less affected by carbon dioxide. And so they play a protective role in this particular instance, although obviously animal source food in general is not, in our diet, we could all do with eating less animal source food. So the people at risk tend to be vegetarians, low-income countries, and future generations. So there's this issue of intergenerational equity as well, that we're putting other people in future generations at risk through our own consumption practices today.
Okay, fascinating. Can you talk to us a little bit about, and don't know if you do know through research or maybe you have suggestions, what we can do? Is there a way to stop this?
Well, first and foremost, we need to stop dumping carbon dioxide into our atmosphere. So that's clearly the most important thing that we can do. In addition to that, we need to encourage more diverse diets in lower income countries where populations are at risk, like in India. There are certain kinds of breeding that might be possible where we could grow cultivars of crops that are less sensitive to rising CO2, and there's some evidence that that might be possible. So starting those kinds of breeding programs would be meaningful. Thinking about supplementation and fortification of diets to reduce these deficiencies, surveillance in these populations to look at what people are eating and ensure that they're not succumbing to these nutritional deficiencies. One of the problems here is that this creates what's called silent hunger. So if you're not getting enough zinc or iron in your diet, it's not the same as not getting enough calories in your diet. You don't get enough calories, you feel hungry and you eat more. But if you get not enough iron or zinc, you don't really feel any different, and so you don't know you have a deficiency. And so we need to do surveillance to identify those populations and then try to intervene to help them. But the most basic thing that we could do is reduce our carbon dioxide emissions.
How do we get this message across to people that we need to, if you're saying we need to act now to prevent things from happening in the future, how do we make that message clear?
Well, I mean, that's a good question, and it's not necessarily, you're moving out of my area of expertise, because it's about messaging and communication and what works best. And I'm not sure. I think one issue is this issue of equity, is recognizing that what we're doing today is essentially mortgaging other people's future for our own consumption practices. I think understanding that there are significant health effects for ourselves as well is important and appeals to people's self-interest. But ultimately, the world just needs to wake up to the fact that we can't disrupt all our natural systems and use the natural systems as an enormous global garbage dump without fundamentally having serious consequences for our own health and well-being.
And I'm wondering, Samuel, are you working on any other research to see what impact carbon dioxide emission impacts any other type of health?
Well, yeah, I mean, so this is sort of the bow around the story of carbon dioxide and nutrients. We've really finished that work with these final 3 papers, although we're now working on a synthesis paper that sort of ties everything together, and we'll be submitting that soon. But carbon dioxide affects health in a whole variety of ways. And so we're talking about a very direct effect of carbon dioxide on the nutrient content of staple food crops. But of course, carbon dioxide is also a very powerful greenhouse gas and a main driver of climate change. So the studies you've been talking about are not studies about climate change. They're studies about carbon dioxide. But of course, climate change creates a whole other set of headwinds for global food production and a set of impacts on nutritional outcomes, as well as affecting things like infectious disease, exposures to natural hazards like Harvey and Irma, as well as fires that we're seeing in the West. So there are a whole series of exposures associated with climate change, independent of the CO2 effect on nutrients, and some of those are things that we're working on.
Well, I hope you will keep us in touch on what's happening with that research as well. This is very enlightening, and I'm so glad that we had a chance to speak with you today on this, and hopefully people will get educated on the impacts that it's making. Samuel Myers is Senior Research Scientist in the Department of Environmental Health at Harvard T.H. Chan School of Public Health, and he's also the Director of Planetary Health Alliance. I would like to thank you so much for joining